Good afternoon, everyone.
Good afternoon, sir.
Am I audible?
Yes, sir.
Okay. So whatever today morning, Rohin, whatever was discussed today morning, all those changes have been incorporated, and the tax marks have been coming. Many of you have got 50 out of 50. So congratulations to all.
Yes, sir.
Very soon you will get your
Yes, sir.
results on your SMS
Yes.
also. Okay. Anyway, so we'll start from where we had.
Yes, yes. Then I got 50 now, sir.
Yes,
So I got 50 right now, sir.
mostly. I'm not sure
Yes.
about marks, but generally many of you have got 50. Okay. Anyways,
Yes, sir. Yes, sir.
so we'll start from where we had stopped. Remember yesterday I had told you about these two problems. We were talking about market risk. Okay, we were talking about market risk, and first we said that we have to measure the market risk in order to reduce it. Without measuring the market risk, how can we reduce that particular risk, right? So so in order to ensure that we measure a market risk, there are two important calculation parameters. The first parameter is the standard deviation and the variance, and the second parameter is the beta calculations, that is the sensitivity analysis of that particular stock. Yesterday I gave you this two problem, okay, wherein I told you how to calculate probable returns. Why probable? Because these returns are supposed to be earned in the days to come. That is the reason we always write the word as probable returns. So whenever we write the word probable returns, we are always talking about the future. And whenever we talk about the future, remember the formula P will come into the picture, and there is no n minus 1 in the denominator. So this is what we discussed yesterday in the yesterday's class. This was the problem and the solution that we had seen. Okay, unfortunately I have not saved the answer. That's the reason the table is blank. But in due course of time you will understand why, how do we arrive at this particular solution. Next, we come to a very important measure, and this is called characteristic regression line. Some books also denote this by the abbreviation CRL. Okay. First of all, if you understand, okay, that there is one important parameter here called as, you know, sorry, there is one important parameter called as linear regression. So in other words, it talks about an equation it talks about an equation such as Ri is equal to alpha 1 plus beta I into Rm plus e raised to I, or Ei. Okay. Now, why do I call it as a linear is because if I change one parameter here, the answer is going to change. If I change beta parameter, the answer is definitely going to change. If I change the return parameter, the answer is going to change. So if any one change is going to happen in this particular right hand side of the equal to sign, the answer is directly going to get affected. So whenever such a equation happens, we call it as a linear equation or a linear regression model. Okay. Now what we are doing, we are estimating what is the amount of risk associated with that particular stock. Okay. For our calculation purpose, let us take a simple example. Let us say that we have a share called as ACC Cements. Okay. And this particular share of ACC Cement, or you can take any share, not only ACC, you can take any share. Let us take the very famous share that is there in the market now. It is very famous. It is Infosys. Okay. So Infosys is somewhere trading at around 1170 rupees. Okay. This is the price of Infosys shares, right? Now if I want to know in the next year, that is 2021, what is the expected return from this particular share in 2021? What am I doing? I am calculating expected return. Please understand, I am calculating expected return, that is the return that is going to happen in future. For that, what do I require? I require my probability, point number 1. Second, there are no n number of observations here, so this n also gets cancelled. There is no n here. Okay, now what do I want to do? I want to find out what is the return that I can expect in Infosys share. So this is nothing but the return for Infosys shares. So whenever there is a calculation for return of Infosys shares, okay, what am I doing? I don't know how much is the return that I can expect from the Infosys shares, but I know one parameter called as alpha. I know one more parameter called as beta, and I know overall how much is the market giving me a return. So when I estimate or when I put all these values in an equation, I can come to a conclusion what could be the probable returns from the Infosys for the Infosys shares. Remember, in the previous slide, we estimated the risk. In this case, we are estimating the return. Clear? So here I am estimating the potential return or the probable return that can be generated by Infosys Limited over the period of next 1 year. Okay. I want to know what is my estimated return or what is my expected return, but I don't know the values, but I definitely know one parameter called as alpha, which is nothing but the intercept. I know one more parameter called as beta, which is nothing but sensitivity, and I know RM. Okay, this is not R mu, this is called as RM. This stands for market return. Market return is nothing but how much is the index giving. This is called the market return. Is it clear? So those notations are mentioned here. Okay, and how do I know whether my share is increasing or decreasing? I can come to know from today's price minus yesterday's price, the whole divided by yesterday's price into 100. If I make a notation of this, I will definitely come to know what is the return that I can expect from the security. But if I want to incorporate all the other parameters, I have to use the characteristic regression line. I repeat once again, what is characteristic regression line? It is a simple linear regression model to ascertain risk. Okay, and how do we ascertain risk? We can ascertain risk based on these parameters. We need to know one parameter called as alpha, we need to know another parameter called as beta, and we also need to know what is the overall return that we can expect from the market. This E is nothing but an error term. Now what is an error term? Error term is some mistake that can happen while calculating. So to do away with that particular part, we have to have an error term. So this error term we take into consideration. If there is no error, this term will not come into picture. Is that clear? Next. Now, when it comes to calculation of beta, how do you calculate beta? A very important part as far as financial calculation is, how do we estimate the value of beta? I hope all of you know this particular regression equation, this particular equation that you have studied. I think you have studied this in your statistics class. Beta is equal to
Yes, sir.
n summation.
Yes, sir. Yes, sir.
Right? So we are going to use the same parameter here. Okay, so this part up to this part is the calculation for beta. This entire part is the calculation for beta. Okay, and once we estimate beta, okay, this is alpha. This is how we can estimate alpha. Okay, I think more than that, all of you have understood the slope of a graph. I think Virgo sir might have told you, this is a graph that you have, this is a line, and if I want to draw the slope of it, I have to judge these two parameters. I need to know what is x and I need to know what is y. Okay, based on this, I can easily come to know what is the slope that is available on this particular line. Okay, and I think all of you know this particular equation. At least science students will definitely know this particular equation called as y is equal to mx plus c. This is the slope of a line, right? Y is equal to mx plus c. This formula, I think all of you know it. The same formula is been just modified here to get this particular answer. We want this answer as y. Okay, so y has gone on the other side, c has remained constant. Okay, and we have come to a particular answer. Now please note down these two formulas. These formulas are important for you. Please note down these two particular formulas. Note down what is the beta value and note down what is alpha value. I will give you 2 minutes. Somewhere, please make a note of this particular calculation or these two particular formulas. Now, whenever you make a note of this particular formula, please understand I am using a highlighter pen to make you understand the value of beta. I repeat once again, beta indicates the sensitivity of a stock with respect to the overall market, right? Now, when we do such calculations here, when you need to understand that whenever we do such calculations such as beta calculations, it is important that we infer the value of this particular beta. That means once we calculate the value of beta, it is important for us to understand how do we interpret the value of that particular beta, right? Now, I think in your in your statistics class, you might have studied regression analysis. You have these two terms called as x and y. Okay, I think in that Veergowda sir might have told you x is an independent variable and y is a dependent variable. Has sir told you all this?
Yes, sir.
X is always an independent variable and y is a dependent variable, right? So in that particular case, my x will always be my index return, right? Index return is nothing but the overall market that can give me a return over a period of time. That is what we call as index return. So x is always denoted with index return and y is denoted with your stock return. Now in my example, my y is nothing but Infosys. Y is nothing but the share of Infosys that I considered in my previous example, right? Now, if I want to know how is my stock, that is Infosys, how is it related to overall market? If I want to know this, I have to establish some relationship between Infosys shares and the overall market. The means by which I can establish a relationship between Infosys and the stock and the overall market is I have to make use of this particular parameter called as beta. So when you use this particular formula, you will be able to arrive at how much is the value of beta. Okay, now I'll just go through the theory part of it so that things are clear to you. So beta indicates nothing but it is the slope of the characteristic regression line. In other words, this particular equation that you just saw, in the previous slide, this particular equation that you have seen in the previous slide is available on that particular graph. I told you this is the slope of the graph. So here this particular equation is available. Okay, so here I have no space, but Ri is equal to alpha plus beta into Rm plus E. Okay, so this equation is available on the slope of this particular graph plus C plus E. Okay, so this whatever this regression equation is there, it is available on this particular slope of this particular line, and we make use of this particular slope to identify the value of beta. Please tell me if it is becoming too much for you. Is it becoming too heavy for you to understand all these parameters, or are you able to understand? I'm waiting for response. Quickly respond, please. Are you able to understand what I'm trying to tell you?
Yes,
So
sir.
it's a little complicated.
Okay. Now, let us quickly go through this. Most all the things are mostly explained here. Okay. Now, suppose I use some data of Infosys, I use some data of the market, and I arrive at a solution. I come to a conclusion that my beta, okay, I come to a conclusion that my beta is say 1.9. Okay. my beta is 1.9. What does it indicate? It indicates that, okay, beta is nothing but the slope of the characteristic equation line. It describes the relationship between stock return, that is Infosys, and the index return, that is NSE 50 or Nifty. It establishes a relationship between stock and Nifty. Now, if beta is equal to 1, what happens? Stock moves along with the index. That means if Nifty goes up by 1%, okay, and if my beta is 1, my stock will also go up by 1%. I repeat once again. If my beta value is 1, if the market goes up by 1%, my stock will also go up by 1%. On the other hand, if my beta value is less than 1, if my beta value is less than 1, if the stock goes up by 1%, if the index goes up by 1%, my stock will go less than 1%. Okay, in this particular case, can somebody tell me, okay, can Dhanashri, can you tell me, if my beta value is 1.9, if my beta value is 1.9, please tell me, if the market goes up by 1%, how much will my stock go up by? I want Dhanashri to answer. My question is, beta I have done my calculation as 1.9. My question to Dhanashri is, if market goes up by 1%, how much will Infosys go up?
Sir, don't know, sir.
You are not attentive, Dhanashri. The answer is in front of you. If your beta value is 1.9, okay, and if the market goes up by 1%, your stock, which is your stock? Infosys. Okay, so Infosys will go up in the market by 1.9%. Now tell me, Dhanashri, if stock market, or if the market goes up by 10%, if the market goes up by 10%, okay, not 1% here, but if the market goes up by 10%, how much will the stock go up by?
Sir, 1.9.
No, it will go up by 19%. See, understand, Dhanashri, you are not able to get the logic here. My question here is, if market goes up by 1%, your share will go up by 1.9%. If market goes up by 10%, okay, if market goes up by 10%,
Yeah.
multiply 10 to this.
Yeah,
Multiply
sir.
10 to this, what will you get?
90.
You will get 19%, right?
19. Yeah, sir.
Your share is going to go up by 19%. Why is this important? It is important because whenever you are thinking of buying a share, you need to take this particular point into consideration, because you need to know what is the beta of that particular share. There are some shares who have a very high beta. That means if the market moves up very slightly, the stock will go up very rapidly up, which is also dangerous, because if the market falls down, the share will fall down in a much faster way. So it is very important for you to understand that whenever you are in a bull run, that means whenever the markets are going up, whenever you are in a bull run, you always need to have shares in your account which have beta greater than 1. Why? Because if market is going up, if the market goes up by 1%, and if your beta is 2, your share will go up by 2%. Right? If you have a beta which is 3, if market goes up by 1%, your share will go up by 3%. On the other hand, if you are in a bearish market, that means when the markets are falling down, you always need to have shares in your account which have beta less than 1. Reason is, suppose in this example, instead of having beta of 1.9, if I have a beta of only 0.9, what will happen? If I have a beta of only 0.9 of Infosys, what will happen? If market falls down by 1%, my share will fall down only by 0.9%. Clear? So these values are important for you to understand which shares to have in your account, which shares you should not have in our account. Clear? So that is the reason we call it as, it is a sensitivity. So here it talks about shares, beta of shares having less than 1, it is less volatile. Here it talks beta greater than 1, it talks about highly volatile. And here it says if you have a beta which is negative, if you have a beta which is negative, which means there is no relation. In other words, if market goes up and if you have a beta which is negative, your stock will go down. I repeat, if your beta of a particular share that you have, if the beta is positive, if the beta is negative, in such case, if the market goes up, your share will go down. Conversely, if the market goes down, your share will move up. Why? Because there is a negative relationship between your share and the market, and that is where beta plays a very important role. Are you able to understand this?
Sir, negative means inversely proportional, sir.
Yes, which means if
We can assume that.
yeah, you can definitely assume that. Okay, it means y is
Yes, sir. Yes, sir.
inversely proportional to x. What is x? X is your
Yes, sir. Yes, sir.
market return,
Market return.
and this is your Infosys. This is your Infosys. So if your beta is negative, if your beta is negative, if market is going down, your share will go up. If market is going down, your share will go up. Why? Because beta is negative.
Yes, sir.
Conversely, if the market is going up, your share will go down. Are you able to understand? Rarely,
Yes, sir. Yes, sir.
very rarely we have such stocks. Generally, we do not have stocks which move in an adverse situation or which move in inverse of proportion. But sometimes you can expect these things to happen. You are getting it?
Yes, sir.
Yeah,
Yes, sir.
any doubts? Okay. Now,
No, sir.
this is how the graphical representation takes place. This is your beta equal to 1. If you look at this angle is 45 degrees angle. This is a 45 degrees angle, which means your beta is equal to 1. That means if market goes up by 1%, your share will also go up by 1%. Here, this angle, if you see, this angle is around 30 degrees angle. This 30 degrees angle, which means beta is greater than 1. What does it mean? If market goes up by 1%, okay, your share will go up more than 1%. Here, this angle is around 60 degrees. This angle is around 60 degrees. In this particular case, my beta is less than 1. What does it mean? It means if market goes up by 1%, my share will go by less than 1%. That is what it means. And if you see this point, these points that are there that you can see on the screen. Okay, these points don't start from here. These points don't start from here. They are not starting from this point. Okay, they are not starting here. Okay, this is not the way. They are starting somewhere on y-axis. Okay, they are starting somewhere on y-axis. What does it mean? This means this is your alpha value. If alpha value is, if the line starts here, alpha value is 0, but alpha value is not here because it is starting from some point here. Okay, in all the cases, the alpha value is something else. Clear? So alpha value is nothing but we can assume alpha as risk-free rate. I don't want to confuse you, but we'll come to risk-free rate at a later stage. Okay, so alpha is nothing but we call it as an intercept of the regression line. It indicates independence of stock return and market return. That means whatever value of alpha you get, okay, suppose my alpha value is say my alpha value is 0.5. What does it indicate? If my beta value is 1.5, I'm just giving a hypothetical example, please pay attention. If my beta value is 1.5, okay, and my alpha value is 0.5, that means if I subtract this, okay, I get only 1%. I get only 1%. What does it mean? It means we agree that the sensitivity of your share compared to the market is 1.5, but out of this 1.5, 0.5 is independent. That means 0.5% of the variation is independent. Only 1% is what you can expect. That is what it means. Okay. So a positive alpha sign, it is not A, by the way, this is alpha. A positive alpha sign is always a good sign to earn higher profits. Okay, so these 3 points are important. It is an intercept first. Second, it talks about the independent relationship between stock return and market return. And third, a higher or a positive alpha value is always a sign of yielding good profits. That is what you are investing your money for, right? To earn some profits. So if the alpha value is higher, it is better. It is a good sign that we have good profits. Yeah, any doubts in this particular case? Any doubts, please?
So the alpha value always changes in the different cases, sir.
Alpha value keeps on changing. I'll show you those calculations.
Yes, sir.
How does it change? First, we'll just
Yes, sir. Yes, sir.
some theory part and then we'll understand. Next slide talks about correlation. I don't think you need any explanation for this. I think you have already studied this correlation.
Yes, sir.
Is this the same formula that you have studied, or you have studied some different formula?
Same, sir.
Okay, please make a note of this particular formula. Has sir told you all this in Excel?
No, sir. Not in Excel.
So that time, yes, sir. Classes were there, sir. That time, first sem.
Yeah, great. But do you know how to do all this thing in Excel?
No, sir.
No, sir.
Has sir not told you how to work out all this in Excel?
No.
Okay, fine, no problem. I will let you know. These formulas look very complicated. They look very clumsy, hard to remember, very difficult to remember all these formulas. But in Excel, it is very easy to remember all this. Okay, because the system will do all the calculations for you. Okay, so whatever I have so far told you about standard deviation, about return, about calculation of beta value and all these things, I will explain to you all these things when it comes to Excel. Don't worry about it. Just in this particular slide, just make a note of this particular formula. Okay, and I want somebody of you to tell me, what do you mean by correlation?
So correlation.
Yeah.
So correlations is basically relationship between two or more variables. So it can be positive, negative. How are the two variables related? So correlation says.
In my case, I'm not challenging your intelligence, but just tell me, if my correlation, that is, if my R value, whatever is this
Yes,
R
sir.
there in the formula, okay, this
Yes, sir.
R, if I get my R as negative, what will it indicate?
Yes, sir.
If my R is negative,
Yes, sir.
say negative, my answer is coming minus 1. Okay, minus 0.0. This is my answer. This is my answer. Please tell me, what does it indicate?
So it indicates that both the variables are negatively related, sir. They move inversely. If one variable increases, other decreases, sir.
Okay. Now, for this, if I just make this positive, what does it indicate?
So both move in the same direction. If one increases, other increases, and vice versa, sir.
Okay. If my R is 0, what does it indicate?
They are not at all related, sir. There's no relationship at all between them.
There is no relationship. Okay. If
Yes,
my
sir.
R is
Neutral.
0.5, positive, by the way.
Yes, sir.
What does it indicate?
So it indicates that they are not that closely related, but still related.
There is only 50% correlation,
Yes, sir.
right? Now, if my R value is, let us say, 0.0, what does it indicate?
So as you said, here it was 50%, here it is 20%.
No, but inference, how
less.
can I draw the inference? What inference?
Inference
Is it
is
a
that
strong correlationship? Is it a weak correlationship? Is it a correlationship which is at midway? What is it?
say it's a little loose correlation.
Okay, the answer is there is a weak correlation.
Yes, sir.
There is a weak correlationship at this particular level. Okay, there is a 50% chance of correlation. That means if this goes up by 1, this will go only by 0.5. That is what it means.
Yes, sir.
Okay, fine. If this is R, then what is R square? Can you tell me? What is R square?
So the square of it, whatever answer we get, we have to square it. Multiply it twice, we'll get the answer.
Agree, but what does it tell you? What does R square tell you?
I don't know, sir.
Don't know. Okay, have you heard of this term called as coefficient of
Coefficient.
determination?
Correlation, yes, sir.
Not correlation, coefficient of determination.
No, sir, not heard. Coefficient of correlation we have heard, not determination.
Coefficient of correlation is only R. Agreed. But
Yes, sir.
whatever R that I get, if I do square of that, I get a concept
sir.
called as coefficient of determination.
Yes.
Coefficient of determination. Now I'll just give you a simple example so that you will understand this. Okay, and then we'll stop it. Anyways, we'll do one thing. We'll proceed with the theory class, and then in the Excel sheet when I open in my next class, I will take a live problem and I'll explain to you all those concepts. Okay.
Yes.
Fine. So up to this point, we were discussing about all the risk part of it. From this slide, we have only returns. Okay, no, we have risk and returns. Both of the calculations are here. Anyway, the problems only start here, so don't worry. In my tomorrow's class, I will be discussing all these problems. Okay, but before, okay, I'll just give you an example. Suppose, okay, my R value is coming to, let us say, 0.80. Okay, and I'm talking about Nifty 50, and I'm talking about Infosys. And my R value is 0.8. Rashmi, tell me whether it is a strong correlationship, whether it is a neutral correlationship, or whether it is a weak correlationship.
So it's less than 1. So it's a loose correlation is what we can say.
No, see, correlation will always, the range of correlation is always -1 to +1.
Yes, sir.
Only in this particular range, the correlation values will come. So 0.8 means it is coming very close to 1, right? 0.8
Yes.
means it is coming very close to 1. That means there is a strong correlationship between the way Infosys shares moves in the market and the way NSE market also moves. There is a very strong correlationship of 80%. 0.8 is what?
Yes, sir.
0.8 is what? It is 80%.
80%.
80% chance that the way stock market moves up, there's a 80% chance that Infosys will also move up in the same direction. That is what it means.
Yes, sir.
Okay. Now, this is my R value. What is R square value of this? What is R square of this? Does it come to 0.64? Just make these calculations in your calculator. 0.8 square.
Yes, sir. It's 0.64.
0.8 square is coming to 64, right? 8 into 8 is 64,
No.
right?
Yes,
Now,
sir. 0.64.
I'm calculating r square. R square is coefficient of determination. Okay. What does it say? What does it say? We can say 6. No, the way Infosys shares moves, the way Infosys shares moves along with the market, we are able to explain it only to the tune of 64% of whatever changes happen to the market. The same changes will happen to Infosys shares to the tune of only 64%. I repeat once again. I have my correlation value is coming to 64. Coefficient of determination value, R square value is coming to 64. What does it indicate? It says that whatever changes happen in the market, and the proportionate changes that happen in Infosys shares, we are able to explain this particular change that is happening only to the tune of 64%. So we are able to explain 64% of the times why Infosys shares is moving along with the market. We can explain this only to the tune of 64%. The remaining part we cannot explain by these particular calculations. We need some more calculations. That is what it says. Okay. I know it is becoming too much for you. We'll stop the class here and I will continue in the next class. Okay. Please stay here. I want to take the attendance. Okay. There are very few people. I think we had a session yesterday. Sir told to you to be regular to the class. Okay. So we have only 23 people who have attended this particular class. Please bear in mind, please attend the classes because otherwise it will be a problem for you. Is that okay? I have taken the attendance. You can leave the session.